Okay, good morning, Veritas scientists. It is March 31st, 2020. It's the last day of March. Tomorrow's April 1st. So let's get right into science today. I hope you watched my lesson from yesterday. That was pretty cool. We looked at some really good soil that I found down at the farm in the cornfield. Then we looked at some sandy soil that I found next to the river in my backyard. And then I showed another video of me down at the farm. I found lots of clay. So I found soil that had lots and lots of clay in it, and it made basically big puddles because the water wasn't able to drain through the clay as quickly as the other types of inorganic matter that we had there, right? The sand, the particles are a little bigger than they are for clay. The particles of clay are so small that when they get wet, they kind of stick together. And I kept saying it was sticky or slimy, right? It was really stuck together because those molecules are so tight that when they get wet, they really stick together and don't allow water to be able to run through them. Where the sand, those particles are a little bit bigger, so they don't quite stick together as much, and the water is able to drain through those bigger pieces a little bit faster, or a lot faster, actually. And then we learned yesterday about silt, so I'll turn this back around. We learned yesterday about silt and how silt is kind of, it's a type of inorganic matter. It was never alive, and it's basically in between the size of sand and clay particles. So sand being the biggest particles, then silt is somewhere in the middle, and clay is really, really small particles that stick together like we talked about when they get wet. All right, so here's the question I had you talk about or think about yesterday. It said, how did a mixture of sand, clay, silt, those are all inorganic matter, so how did those and organic matter all become part of the soil at the farm? Where did they come from? So we were looking at soil, we saw that these different ingredients are in the soil. And my question to you was, where did they come from, right? Did the farmers put them out there? No. So we're going to learn about a couple of processes now. You've probably heard these words in the past, but we're going to learn a lot about weathering and erosion. So here we go. I drew a couple of pictures. I will explain what this is, and then today my job is going to be to go out and find some cool examples of weathering and erosion that happen in the real world. Okay, so today is Tuesday, March 31st, 2020. We're talking about science, weathering, and erosion. Here's some vocabulary you're going to need, but I want to think about this saying here first. It says, weathering breaks it, erosion takes it. So we're going to talk about these two words, weathering and erosion. But that's a good little saying that I used to use when I was in 5th grade to remind myself of the difference between weathering and erosion. A weathering breaks it, erosion takes it. Okay, so weathering, let's start with number one, vocabulary. It says, when forces of weather, such as wind, rain, sleet, snow, hail, etc., break off small pieces of rock from a larger piece of rock. Okay, so weathering is basically when the weather breaks little pieces of rock off of bigger pieces of rock. Okay, so here's my little drawing. There's a mountain, and there's a big rock on the mountain that says rock. Okay, so when wind hits it, the wind is blowing against the mountain, it's hitting against this big rock here. Then rain and snow and hail and sleet, they hit the rock every time it rains or every time it snows or hails or sleets. That is all smashing up against the rock. So the wind is hitting it, the rain is hitting it, all those different types of rain are hitting it. And weathering is when those little pieces of the rock break off. So little pieces of rock break off from the bigger piece, that is called weathering. So it's just the pieces that are breaking off. We call that process weathering. So the little pieces aren't called weathering. The process of this happening, right? These pieces breaking off is the weathering part, okay? So that's the first one. Weathering breaks it. So the weathering is when it actually breaks off into littler pieces, okay? And weathering usually happens very slowly, right? Weathering takes thousands and thousands of years usually, or hundreds of thousands or millions of years. It takes a really, really long time for pieces of rock to break off of other pieces of rock, right? It's not something that you can watch and have it happen in a day. It takes a long time, okay? Usually we're going to talk about some examples when it doesn't take a really long time today. Number two says erosion. It's when little pieces of weathered rock move from one place to another. So like we set up here, Weathering breaks it. That's what breaks the little pieces of the rock off. Erosion takes it. So erosion is the movement of those little pieces of rock from one place to another. All right, so here's my drawing of a river. The arrows mean that the river is going in that direction because the river water is always moving down in elevation to a lower point of elevation. So the brown is supposed to represent, the brown dots are supposed to represent little pieces of rock moving down the river. So when the little pieces of rock, that's called sediment. We're going to talk about that maybe tomorrow. When those little pieces of rock or those little pieces of sediment get into the water, they are going to move down the river with the moving water. And the movement of those little pieces of weathered rock is called erosion. And again, very important, erosion usually happens very, very slowly. It takes thousands of years or hundreds of thousands of years for those little pieces of weathered rock to move from one place to another. Okay, erosion happens a little bit quicker than weathering. Weathering is really, really slow as a process, right? Unless something big happens. I don't want to give you too much information because that's what the question is going to be about in a minute. But weathering usually takes a really long time. Picture a rock out maybe in your yard or a big rock that you've seen somewhere. That rock has been there your whole life, right? At Kelly School, there's a big rock, I remember, in the back, way out in the corner of the field. Since you were in kindergarten, that rock has still been there, and it's still been the same size. But weathering is happening to that rock. Very, very slowly, little tiny pieces of that big rock in the back of Kelly School are breaking off. That rock is weathering. And over a long, long period of time, if we came back in 1,000 years, we're going to see that that rock is going to be a lot smaller because weathering is going to have happened and lots of those little pieces of that rock are going to have broken off. Okay? So weathering breaks it, erosion takes it. That's our lesson for today. Here's the question I'd like you to answer tonight or right now. Today's Tuesday, March 31st. It says, give one example of when erosion happens quickly and give one example of when weathering happens quickly. So like we said over here, they take a very long time to happen. Weathering happens very, very slowly. Erosion usually happens very, very slowly. So we want you to think about when would it happen quickly? When would erosion happen real quickly? And then I want you to think of an example of when weathering would happen really quickly. And we will talk about that tomorrow. All right. Good luck. Watch out for my videos this afternoon. I'm sure I'll come out with one at some point today. So keep an eye on that. We'll be talking about erosion. That way you can really see a good video of what that looks like. All right. So I hope everybody has a great day. We'll see you on Wednesday. Thank you very much for watching and take care.